Hello students, this is Dr. Obujit Shah from Chemistry Department of SRM IST. In this video, we'll discuss the determination of molecular weight of a polymer solution by viscosity average method. Actually, polymer solution, actual molecular weight determination is very difficult because in polymer solution there are, we know that polymer is a molecule is a macromolecule where there is a repeating unit of monomer unit. Now, let's say in some polymer there are 100 repeating unit, some polymer there may be 101 repeating unit, some polymer may be there is a 99 repeating unit. All polymer, when we are making a polymer, it is not possible to make every that all polymer have the same number of repeating unit. So in case of polymer, we cannot measure the exact molecular weight. We have to calculate the some average molecular weight. So for that we need some, there are different methods. So today we'll discuss about viscosity average method, how we can use this viscosity. Viscosity is a properties of polymer. Polymer solution is highly dense, density is high because of in polymer there are many cross linking, so density is high. So polymer solution are a viscous solution. Now using this property, viscosity property of a polymer, we can determine its molecular weight. Average molecular weight we can determine. So in this experiment we'll discuss about that thing. So this experiment, this video you can consider in virtual laboratory, because how we are performing the experiment in laboratory, the same thing is described in this video. First I'll talk about a little bit about the principle, little bit about the background of the experiment. Then I'll show you the video. That video will show you everything about the experiment, how we will perform the experiment in laboratory. So for background means first I have to tell you that a polymer solution means a viscous solution. Now this viscosity depends on the concentration. Say if we have 0.1% polymer solution and 0.2% polymer solution, what is the difference? Difference is their concentration. So if we increase the concentration, there are more molecule. If more molecule means there will be more intermolecular force, solution will be more viscous. Now we can determine this viscosity. For determination, we have some viscosity Oswald viscometer. What is that viscometer? In that it is a glass instrument. I will show you in the video. Where there is a capillary. In capillary there are two markings. So marking 1 and marking 2. Marking 1 and 2. So when some liquid is passing from marking 1 to marking 2, we can calculate the time. Okay. Now if the solution is more viscous, then it will take more time to pass this to mark. If solution is less viscous, it will take less time. So if we pass 1% polymer solution and pass 2% polymer solution, then 3% polymer solution, what will be changed? Change will be in the timing. So 1% less viscous, so it will pass 3 quickly. 2% more viscous, it will take more time. 3% much more viscous, it will take much more time. Like that. So in this, so time is a very much proportional with the viscosity. So if we increase the viscosity, it will increase the time, required time to pass that solute to marking, it will increase. So by measuring the time to pass through the capillary of the different concentration of polymer solution, we can measure the molecular weight. So for that we have this formula K and M to the power A. This M is the molecular weight, K and A is the constant. And how we are, okay, and this is actually our viscosity. There are different type of viscosity, specific viscosity, reduced viscosity. Okay, but viscosity, it will be the proportional, reduced viscosity, it is proportional to K M to the power A. M is our molecular weight. So from the experiment we'll determine this N value. We'll determine this Ni value from the experiment. Okay, and K value and A value will be given. Then we will put this K value, A value and N value in this equation. We will get the molecular weight. This is the principle of the experiment. Now I will show you the video. Okay, next slide. There is a full video. You can understand.
Title: Determination of molecular weight of polymer using viscometer.
To determine the molecular weight of a polymer, we use a viscometer. Let me show you how. This is an Oswald viscometer. We use the stopwatch to time the flow. The pipette draws the liquid, and these are our samples.
Reagents required: polymer, PVA, and water. First, pour the PVA powder into the water. Then, stir the solution until it is uniform. First, select a solvent where your polymer is completely soluble. Here, PVA dissolves in water but not in ethanol. The water solution is clear, ensuring an accurate viscosity measurement. Prepare a dilute polymer solution using the solvent. Dilute solutions are important because the density of the solution is approximately equal to the density of the solvent. Take a clean and dry Ostwald viscometer. Fix it vertically in the stand. Fill the viscometer with pure solvent. Using a suction bulb, draw the liquid above the upper mark. Allow it to flow down freely under gravity. Measure the time taken to pass between the 10 marks.
You can
First,
see
empty the
here,
viscometer
there are
and
two
rinse it with the
markings.
polymer solution. Now, fill the viscometer with the polymer solution. Cover the tube, draw the solution up, and release to start the time the flow between the marks. Repeat for accuracy and record the average. We must ensure the temperature remains constant at 25 degrees Celsius throughout the experiment. The digital displays confirm temperature and pressure are stable. Hydrostatic pressure is unchanged, maintaining reliable conditions.
Step 7. Apply Poiseuille's relation. The formula is eta over eta 0 equals rho over rho 0 times substitute the given values. The density ratio is 1.1 and the time ratio is 1.32. For dilute solutions, we assume the solution density is approximately the solvent density. This simplifies the relative viscosity equation to a ratio of flow times. This simplification is key for practical use with viscometers. To calculate relative viscosity, use this formula. Relative viscosity is the ratio of the solution's time, T, to the reference time, T arrow. The relative viscosity is 1.5. Specific viscosity, eta sp, is defined as eta sp equals eta minus eta 0 divided by eta 0. Eta over eta 0 is relative viscosity, eta rel, so eta sp equals eta rel minus 1. Step 1. Calculate reduced viscosity. First, determine to then apply the formula. For example, with a specific viscosity to 0.45 and a concentration of 0.5 gram per deciliters per gram. Step 2. Determine molecular weight using the Mark-Hawink equation. We start with the relation. Intrinsic viscosity equals K times molecular weight to the power of A. Substitute the values for K and A for PVA. To find the intrinsic viscosity, we plot reduced viscosity against concentration. The intercept gives us the intrinsic viscosity as shown in the graph. The stopwatch records the time as the liquid flows through the viscometer. For dilute polymer solutions, the plot of reduced viscosity versus concentration is a straight line. The intercept of this line, as concentration approaches 0, gives the intrinsic viscosity. First, decide the required concentrations, 0.1% and 0.0%. Next, use the formula to find the stock volume for each concentration. Finally, make 10 ml of each solution and label the tubes clearly. First, draw up 5 milliliters of the stock solution. Now, dispense it into the volumetric flask. Rinse the pipette with distilled water. Swirl the flask to mix the solution.
Marking this one as 0.1 m. Next, 0.5 m and 1.0 m. All labeled and organized, ready for the experiment.
As the concentration of the polymer solution increases, the time of flow also increases. This data allows us to calculate the relative, specific, and reduced viscosity for each solution. The molecular weight was determined using the viscosity average method. By measuring viscosities at different concentrations and extrapolating to find the intrinsic viscosity, the viscosity rate was Lacarne variation.
Okay, so this is the full method. Okay.
Title: Determine
So this is the graph we'll get after this experiment. Okay, so we have to extend this line to the y-axis. When it will intersect the value, the intersect is the called Ni value. Now we have to put this Ni value in the equation. K and M value already given. We can get this viscosity value. So this is our method. This is a table already described in the video. Okay, this is the calculation part. Okay, so I hope you have understood about this experiment. Thank you.